Hi, my name is Yee Yit. Metric ID is TL23012. So I will briefly introduce our project on developing a virtual instrumentation system for sound data acquisition and analysis using a microphone sensor. A microphone sensor is a transducer that converts sound waves into electrical signal, playing a crucial role in modern technology. From simple voice recordings to complex audio processing, these sensors translate acoustic energy into electrical energy, enabling applications in communication systems, entertainment, and industrial environments. Different types of microphone sensor have unique operating principles and are tailored to specific use. For example, in manufacturing facilities, microphones serve as essential components in quality control system, detecting abnormal machine sounds that could indicate maintenance needs or potential failure. These acoustic monitoring systems help prevent costly breakdowns and optimize equipment performance. In industrial safety system, microphones function as part of noise monitoring equipment to ensure workplace compliance with occupational safety regulation and protect workers from harmful sound levels. The objective of this project is to design and implement a virtual instrumentation system for data acquisition and analysis using a microphone. The system aims to capture sound signals, process them in real time, and analyze their characteristics in both time and frequency domains. This setup is intended to demonstrate the practical application of vibration and acoustics measurement, specifically using a vacuum cleaner as the sound source, and to highlight the effectiveness of a simple, accessible instrumentation system involving a smartphone and laptop. Next, I will move on to the next part, which is the first experimental setup. For hardware setup, we use smartphone and laptop for this project. Smartphone is equipped with Decibel X app to measure and monitor sound pressure levels, SPL in decibels. This was used to measure and display real-time sound pressure levels of the vacuum cleaner, while laptop was used to run DaisyLab software to analyze the signal, generating time and frequency domain plot. For the DaisyLab layout, we began by launching the software and configuring the input module. We start the setup by clicking on Modules, Inputs and Outputs, Driver to insert the analog input. Then, to visualize the data, we added a digital meter by selecting Modules, Display, and Digital Meter. Then, click on Restore Display Windows in DaisyLab to display the value of the digital meter. Click on Start button on DaisyLab and Decibel X app simultaneously, then turn on the vacuum cleaner for the sound. The value that we get from the first setup earlier is then put in this formula, which is dB equal to 20 log VRMS over V reference. The value displayed on Decibel X app is 84.1 decibel, while the value displayed on digital meter on DaisyLab for VRMS is 0.08 volt. These values that we get after turn on the vacuum cleaner sound is used to find the V reference using the formula given. By rearranging the formula and substituting the values, the answer for the V reference is 4.99 times 10 to the power of negative 6 volt.
After getting the value of V reference, we proceed to the second experimental setup. First, click on the module, choose the mathematic, and choose the formula interpreter. After that, double-click it to key in the formula that is given, which is 20 times log times ln 0 divided by V reference. After that, we will insert the right data, which is click on the module, choose files, and insert the right data. The first picture is show the connection between the analog, digital meter, formula, and also the write data. This setup is done for analyzing and recording the value of an analog signal source. So we'll proceed to the next. We click on the modules, choose the displays, and insert the YT chart. After insert the YT chart, we double click it and we take the auto scaling and copy input and make sure it's connected to the analog and set the name as time domain. After connecting the YT chart to the analog, we will continue to insert the data window and also the FFT. So we will click the module, choose the signal analysis, and choose the data window and also the FFT. After insert them, we set the block size to the 4096 for data window and make sure it is in rectangular shape. After that, make sure the white chart is connected to the FFT, take the auto scaling, and set the name as the frequency domain. Based on the picture, it is clearly show that the YT chart before the data window is to display the time domain, and after the FFT is to display the frequency domain. Last, complete the layout of the module setup. We will continue to click the Start button to display. After complete recording from the vacuum cleaner sounds, we'll get the result based on these two diagrams, which is from the time domain and also the frequency domain. If you look at the frequency domain graph, it shows the value is around 650 Hz.
Hi everyone, I will continue for the discussion. So in the discussion, based on the data collected above, different results obtained from decibel X and decilab with voltage of 0.868 watt and 102.73 watt, showing different results in time domain and frequency domain graph. Each result can express with the decibel X showing a real time of sound pressure level SPL, which displays in a single instantaneous level. This function will lead the data with quick monitoring but lack detail and accuracy of visualization of amplitude over time. For Decilab software, it was allowed to be showing continuous waveform representation of the sound signal, and it will lead the amplitude variation in displaying state will show with accurate and detailedly and help us to learn more about the periodic nature. Next, for the frequency domain, decibel X also did not showing and provided the frequency spectrum analysis, and it only focused on sound pressure level measurement that collected before. However, Decilab software was showing detailed frequency domain plot and showcase about the distribution of sound energy across a variety of frequency, and this analysis helped to identify the frequency domain that associated with the vacuum cleaner motor vibration, airflow, and mechanical oscillation. For conclusion, in summary, this experiment was successfully demonstrated the analysis of sound signal that generate by vacuum with both air, which is decibel X and decilab. In decibel X, the app will more focus on sound pressure level monitoring, while decilab software provided more detailed and comprehensive analysis by capturing the continuous waveform, and that is more accurate than decibel X. That's all for me. Thank you.